Let's take a look at this example. We have series circuit which contains voltage source, resistor and capacitor. We're supposed to find the following quantities. In order to find Z total, we can simply add the resistance with the capacitive reactance or impedance of the capacitor, we can say other words. So Z total is equal resistor plus the capacitive reactance X of C. So this is equal 2 kilo ohms plus 1 kilo ohm, but don't forget that X of C goes always with angle of negative 90 degrees. Use the calculator and you're supposed to get the value of 2.23 kilo ohms and angle of negative 26.56 degrees. So this is the total impedance of this circuit. Next, we're supposed to find I total. In order to find I total, we're supposed to use Ohm's law, which says current I total is equal voltage source over Z total, where voltage source is given, we have 200 volts, and if angle is not given, there is always angle 0 degrees, divided by Z total 2.23 kilo ohms and angle of negative 26.56 degrees. Okay, you're supposed to plug in these values into the calculator and you will get the value of current 89.68 milliamps and angle of 26.56 degrees. Now, this is my total current, but don't forget that this is series circuit. So if we talk about the series circuit, the current in every single part of the circuit is always the same. So I total is equal to IR, the current which goes through the resistor, and is equal to IC, the current which goes through the capacitor. So all of them are going to have this value. Next, we're supposed to find voltage across the resistor. I'm going to use Ohm's law to find the voltage across the resistor. Ohm's law says voltage is equal current times resistance. So if VR is equal IR, the current which goes through the resistor. In this case, the current is equal to I total. If you are going to write I total times R is also correct, times resistance. Okay, voltage is equal current times resistance. So current is equal 89.68 milliamps times angle of 26.56 degrees times the resistance, which is equal to 2 kilo ohms. Okay, use the calculator and you're supposed to get the value 179.36 volts and angle of 26.56 degrees. So this is the voltage which we are going to have across the resistor. Next, we're supposed to find voltage across the capacitor. So if VC is equal IC, the current which goes through the capacitor, times X of C, which is equal 89 26.68 milliamps, and angle of 26.56 degrees times the capacitive reactance, which is equal 1 kilo ohm. And don't forget that the capacitive reactance or impedance of the capacitor goes always with angle of negative 90 degrees. Okay, so plug in these values into the calculator and you're supposed to obtain 89.68 volts and angle of negative 63.44 degrees. Next, in order to verify that our answers are correct, you're supposed to apply KVL, Kirchhoff voltage law, which says that the sum of voltage drops across each component in the series circuit is supposed to give me the value of voltage source. So I'm supposed to write voltage source is equal voltage across the resistor plus voltage across the capacitor. So voltage across the resistor is equal 179.36 volts, this is this value, and angle of 26.56 degrees, plus voltage across the capacitor, which is equal 89.68 volts and angle of negative 63.44 degrees. If you are going to use the calculator and add these two values, you're supposed to get 200.53 volts and angle of negative 0.005 degrees. So 200.53 volts. Okay, so this value, okay, is very close to 200 volts. And this angle, we can say this is 0. Okay, so because I had no given angle means there is angle 0. So I can say that the voltages which I found are correct. So up to this point, everything goes fine. Next, we're supposed to find the power factor. The formula for power factor is, this is one of them, power factor is equal cosine of angle theta. So this is the cosine of the angle which is next to Z total. So I have, in this case, so I have cosine of negative 26.56 degrees. Again, you're supposed to use the calculator and you're supposed to get the value of 0.894. Now, because we are talking about the RC circuit, you're supposed to realize that in this circuit, current is going to lead the voltage source. So that's why we're supposed to, next to the value of the power factor, write lead. Okay, so this is the answer for my power factor. We do so because if you are going to look at I total, you will have the angle 26.56 degrees. And voltage source has angle 0. So we can see that the current total, or source current, leads the voltage by 26.56 degrees. So anytime current total leads the voltage source, we're supposed to write lead next to the power factor in the particular problem. So basically we found everything whatever was to find, so we can say that the problem is solved.